Hi, in today's video I would like to introduce you a very nice proof regarding the chain rule. Here is the following statement. Satisfy this condition. We have the derivative function of this composition is contained two functions, f of g of x equal to g prime of x as a first derivative function is multiplied by this derivative function of the composition, which is f prime of g of x. In order to prove this rule, we are going through derivative function definition, which is the limit as h goes to 0, f of x plus h minus f of x is divided by h equal to f prime of x as a first derivative function. Okay, so now let's get started. Let's set y equal to f of g of x. I'm going to apply the first derivative function on both sides. Notice we have the composition form of this function. We are going to use that rule of the derivative function definition. The first derivative function with respect to x equal to the limit of f of g of x plus h minus f of g of x divided by h as h goes to 0. What I'm going to do now, I leave this one as is it. I'm going to multiply by g of x plus h minus g of x is divided by itself, which is g of x plus h minus g of x. Okay, as I did nothing, just dividing this one by this one, which is 1 equal to 1. So now I'm going to rearrange this one by switching h underneath of this one and bring back this one underneath of this one. So I will get dy over dx as the limit goes from h to 0, f of g of x plus h minus f of g of x divided by g of x plus h minus g of x is multiplied by g of x plus h minus g of x is divided by h. Okay, so as I'm applying the limit on the first term, I will apply the limit on the second term as well. So I will have a limit as h goes to 0. This expression is the same thing as this one. Okay, so this one equal to g prime of x. Okay, as the first derivative function definition. Okay, in the same time I'm going to do the substitution of this one. I'm going to set g of x plus h minus g of x equal to p. Okay, so I'm going to rearrange these two terms. I will get g of x plus h equal to p plus g of x. Okay, if you take a look again at this function, if h goes towards 0, that's mean I will get g of x equal to p plus g of x. So this g of x will be cancelled out, so I will get p equal to 0 as well. Okay, if h is approaching to 0, that's mean p is approaching to the 0 as well. So now by doing the substitution, so I will get dy over dx equal to the limit as p goes towards 0, because we found out p is going towards 0. So this one, I'm going to replace g of x plus h with these two terms. I will get f of g of x plus p minus f of g of x is divided by p. Okay, is multiplied by g prime of x, which we have proven before. Okay, This one is satisfied the limit definition, which is f prime of g of x, okay, is multiplied by g prime of x, which is d, the derivative function of this function, which by doing the first derivative function respect to the x, I get this one equal to this one, okay. So when we derivate this one, we get this one equal to g prime is multiplied by f prime of x. This is chain rule, okay. Now I have proven this rule. Don't forget to support us by subscribing and like. Thank you for watching. I will see you in next video. Bye.